Okay, the differences between physical properties and chemical properties should start off with some definitions. The first, physical properties are those characteristics that can be observed or measured with no change. So, in other words, there are certain characteristics that you can witness and observe without the matter changing its chemical properties. You know, water will still be water, H2O, whether it's solid, liquid, or gas. But I'm getting ahead of myself here. So, properties that can be observed or measured with no change, and chemical properties can be observed only by a chemical change. So, when you observe this chemical property, that material is changing into some other material, and maybe that'll become more clear to you as we go along. So the first set of properties are physical properties, and the first one is state, meaning whether it's a solid, liquid, or a gas. So if this were water, if it was water as a solid, it would be ice, but the molecule would still be H2O. As a liquid, water would still be H2O, and as water vapor, as a gas, the molecule will still be H2O. So in the definition, I mentioned that there would be no change. So the H2O is in a solid or liquid or a gas state, yet it's still H2O. So that's a physical property. All right. Color is a physical property. The color that's unique to that substance. Now, if you paint something, it doesn't really change the color of the object. You're just putting a different color on top of it. All right, so if I have a brown rock, it's still a brown rock. If I paint it red, it's still a brown rock, but I put a coat of paint to cover it up, to hide it. So the color isn't really changing when you paint something, if you think of it like that. The next is solubility and boiling point. Solubility is its ability to dissolve in water. All right, so for instance, salt. If you put salt in, the salt dissolves, and you can't see it anymore, but it's still salt. It hasn't had a chemical reaction. It hasn't changed into something else. The salt is still salt. You sip the water, and you can still taste the salt. Boiling point is going to be unique for every liquid. So for water, it's 100 degrees Celsius or 212 degrees Fahrenheit, and that's going to be the same for all water, basically, depending on where you are and what the atmosphere is. But it's going to be close to 100 degrees Celsius, and the water is still going to be water. Texture, whether or not the matter is smooth or rough. And again, it's something that you can observe, but it doesn't change. There's something called malleability, which is the ability for you to be able to take a hammer and pound it into sheets, or to just reshape the material. And like malleability, there's something called ductility, which is the ability to stretch it into a wire. So if we take copper, we can stretch it out and bend it into wire, but it's still copper. And then we go into chemical properties. And remember, our definition of chemical properties is that it's observed only by a chemical change. So one important to remember is flammability or combustibility, which basically means the same thing, just at different temperatures, really. There is a distinction. There is a difference, but that's basically the same. And that's the ability for something to just catch on fire, right? And you don't know if something could catch fire until you see it catch fire, right? So to witness it, you have to change it. Another one, toxicity, and what that means is just whether or not it's poisonous or not. So when you see this label, right, you know that it's toxic, it's poisonous, you stay away. And the next one, oxidation. In other words, if it rusts. So we have these nails here, and we have this old car, and the metal is rusting. And that's called oxidation. And the metal is changing because of this chemical reaction with the oxygen in the air. And so that metal is no longer the same metal. It's changed into a different molecule. And then we'll have one more, and that's reactivity. And reactivity you've seen, maybe in the science lab with baking soda or vinegar, and here's some pictures of certain chemical reactions. And fireworks, explosions would absolutely count as a chemical reaction. And once these things happen, those molecules are no longer the same substance. It's changed to something else. So chemical properties is when there's a chemical change, and that includes fire, right? Toxicity, oxidation, and reactivity. And then here, physical properties can be observed or measured with no change. That's changes in state, color, solubility, boiling point, texture, malleability, and ductility. All right, I'm sure there's a few that I've missed, but hopefully you get the idea. All right, thanks for watching.